Okay, hi everybody. Thanks a lot for being here with so many interesting talks happening. I'm honored that you chose to be here, and yeah, I hope I'll do you proud. So, after that, the Kenny's talk, I think you're all familiar about what Jamstack is. It's basically an architecture for JavaScript, APIs, and markup. So this idea is, I'm going to talk here about how we're going to use the Jamstack architecture to scale our apps from their very conception to a large app that is easy to ship sustainably. So before we get further, my name is Atila, or Atila, or well, whatever accent you have, I'm fine as long as I understand. I'm originally from Brazil. Now, today I live in Germany, and I work at Signavio, which is a company from SAP, as a lead front-end engineer. If you want to know anything else about me, that's my website. All the links are there. And let's get started. So once we work with a web application, and especially at a startup, we have this happy path. And we usually envision something like this. Somebody has the app idea. And then we build, we ship as fast as possible, we validate this idea, and in a perfect world, we just keep shipping and make our product bigger, and we keep going sustainably. But most of us kind of know that's not how it happens, at least not most of the times. So how every startup actually starts up. Basically in the same way, so we have the app idea, and we need to build and ship and validate as fast as possible. But once we do that, we get ourselves scratching our heads on, okay, so how do we scale past that? And how do we maintain this app? And now that we shipped, I want to improve this app, and I want to make it better. I want to get a bigger share of my market and whatever else. And then that's how most companies end up going through a period of rebuilding the app and refactoring the app and getting ready to ship again, so then we can finally ship something sustainably. So we can finally just increase features without generating technical debt. Fingers crossed. But that's a very much product-y approach. So how it happened on a developer perspective, at least in my opinion? We are told to build a very simple app as fast as possible because we want to keep investment low, and we want to make sure that we have this market share. We want to make sure that whoever is investing on us, and we want to make our statement in the market. Once we get to that, realize, okay, that's not enough. We need to build more. But we haven't planned for that, so we go into this period after validating where every feature we build, it kind of generates a little bit of friction, and we start realizing, okay, the ceiling is not that high. We need to, at some point, refactor a little thing, and while we have a small code base, it's rather okay. Like, it's okay, we build something, and then we can take a day or two, maybe, to refactor something else, to make things, but at some point, we realize, okay, this is not going to work out. Like, I'm going to have to stop at some point. I'm going to have to make something that I can just ship and not worry that much about it. Right? And then that's where we get to the phase of refactoring stuff. And that's very common. Some of us have been there, like, sometimes more than one time in our career. And nobody likes that. And if we all hate that, if we actually want to ship features, because that's what we do, we want to ship nice products that everybody uses, right? So if nobody likes to be in that position, why do we always get there? So we take a step back to that validation phase, because we started as we planned. We had an idea, we validated the idea. But how the things fell off track after that? So let's take a look about how the context goes. So that's the context of when we build an app. So we bring as fewest people as possible because we want to keep the investment as low as possible. We want our product, our company to be lean, because the more people we have, the more expensive it gets, because people need salaries, right? At least I do. And then because we have few people and very little scope, and we just want to validate that core idea, we end up having a small code base. And with small people and with little people, few people, and a smaller code base, what we get is smaller decisions because we don't have that much scope. We don't have that big of a code base. We don't have that much code. So it makes a lot of sense to just build a single page app. Because with a single page application, what we get is a very low cost delivery. Some single page applications are just a bunch of static files that we put on a CDN and we just throw it to the client. We throw it to the browser and it just parses and renders it. You have an easy setup because a lot of single page applications, we can just say, Yarn, create my app. And that's it, right? You can just start shoving your business logic there. And because you have a low cost delivery and an easy setup, and it's a kind of an architecture that's already done so many times, it has a quick deploy. Like, you find resources very easily to get there. So at that point, for that validation period, a single page application makes tons of sense, right? If you need something, you can just get a resource from the community, bring it in, and you can validate the idea. And, well, scalability is kind of tomorrow's problem. So in this case, let's speed up things a little bit and get to the point where we actually want to scale our stuff. So how do we move from one app, one core, one application, to many goals, since we have not actually planned for that? So we need to add more code. We need to have more teams because we have more tasks to fill. And because we have more code and more teams, we actually need more people. But more people are going to bring more opinions. And more teams have more priorities. And more code has more integration points. So at this point, we start scratching our heads and think, OK, we should have something like microservices, but for the front end in this case. Right? It will make sense. It works so well. Microservices are awesome. So let's try a shortcut. Famous last words. We are going to make a component library. And heads up, like a lot of people already call that a micro-frontend. Personally, I don't. I call that kind of a component library. I'll show you more later. But we have all these parts of our application. We're going to cut them, and we're going to make them into separate apps. So each component are going to actually be their own app. And we are going to wrap all that into JavaScript. Because we're on the browser, we need JavaScript. And we wrap into JavaScript because the JavaScript is actually going to listen to lifecycle events. So sounds familiar, right? Like on-mount, unmount, this kind of stuff, to make sure what is the actual moment that those apps need to be run or need to execute or are going to be interactive, right? So OK, so now let's look at what we have. What we want is end-to-end ownership. We want every team to be able to handle their part of the application from the very beginning, when they get the requirements, to the end where they deploy. So to that, we're going to give every team their own app. We're going to break our interface into components, and we're going to say each component is their own app. And then we are going to integrate everything on runtime. So let's look at our requirements. We have a bunch of opinions, we have a bunch of priorities, and we have to integrate everything in the end. So we broke the interface in components. And we give every team their own app, so they can make the decisions themselves. That's fine. So we don't have to put 50 people in a room and make them get to a decision together. They can go all the teams of, I don't know, 5 people, 8 people, and it's much easier to get a consensus when you're less people than a lot, right? And because they each have their own app, all the priorities are going to be met because each app is like their own scope. So they don't need to fight for which priority they need to ship first or whatever, because they are all handling everything end-to-end. But we don't get integration at this point because we are going to put everything on the browser, and we don't really control the browser, right? And then that's when things start to smell funny, because systems get volatile if we get like multiple dependencies to do one task, because everybody has their own priorities and their own stack. We end up having, sometimes unless we have very strong conventions or something like that, it's hard to make them ever communicate and reach the same decision. And another kind of problem is when we have multiple versions of the same dependency because one team updated faster than the other. And inherently, and sometimes that just means we have multiple dependencies. And on top of all that, our system is running actually in an uncontrollable environment because we don't know which browser it's running, we don't know which device it's running, and we don't know how. So it's very little control to something so important as our entire product. So to illustrate this a little bit more, let's break down into 3 components. So 3 apps for this our product. So app A is going to have React, DataFNS, and Redux. So DataFNS handling some dates, Redux handling some state. And in this case, I'm considering only different versions for React just to make things a little bit simpler. So I just put a random number there, but so A and C are using version 17. B is using 16, and instead of DataFNS, they chose Moment.js for one reason or the other. At least they're still using Redux, which is the same as A. But C is using DataFNS for dates. Nice, some consensus. But they decided the observable pattern was better for them, so they went with MobX. What happens when we ship everything to the browser is that, oops, spoiler. So is that each app is going to actually be rendered, each version of the app is treated as another one. So everything ends up in the bundle. So whenever we have the same version and the same dependency, that's fine. But if they have different dependency and they end up different versions of the same dependency or different dependencies, that's when our bundle gets big. And well, that's when things start to get problems. So I don't want to tell you what happens. Nobody wants to find out what happens if the context on app B tries to fetch data from a provider on app A, right? Since they're different instances of React. And in the end, it's still like one very big single page application. It's not really decoupled. It's not a perfect equivalent to microservices because we ship everything separated. But once we get to the browser, once we get to our end user, it's one big thing with all the hiccups of being decoupled. And so we already talked about the performance issues, about having a bloated bundle. Well, what happens when you need to mount everything on JavaScript in a situation where you don't have JavaScript, right? And then we start thinking, okay, so not everything is supposed to be assembled on the client. And that's where Jamstack comes in. So we're going to take a different approach. We're going to still go with the micro-frontends. We're still going to try to decouple our stuff. But we're going to have isolated apps, and we're going to put them into the same domain. We're going to wrap them into this same location. And we're going to lift the integration stage to the backend. So we're going to have these shared services, which are just going to be Lambda functions in the end. And that's where we're going to synchronize our data. So if that sounds familiar to you, before single-page applications, we had all the logic on the backend, and then the front end was basically a consumer. Then with single-page applications, we realized, okay, we need to give more power to the front end. So everything went to the client. The entire logic, our apps were like all powerful. And now with the Jamstack, what we want to do is have important pieces of the logic on the backend handled by our Lambda functions, sorry, or our backend for frontend, and then still having the autonomy on our apps whenever we ship them for them to be handling this kind of the logic. So let's go again. We still want end-to-end ownership. We still want to give every team their own app, but now that we learned a little bit from our past experience, we're going to change a little bit the other requirements. We want to integrate everything with microservices because we already know it works very well for the backend. And because we want to handle the fact that sometimes we don't have JavaScript at the front end available, we want to serve static content for our clients. So in this case, there's one caveat though. We're going to use a data-only integration at this point. So we are not actually we don't have that granular that we would have in a component library. We are integrating only the data in this point. So our Lambda functions can talk to each other, and then they talk to the CDN, and then the CDN talks to our client. That's how our integration is going to happen. And a pro tip, since we're going to do those shared services, use the platform. So we have a very strong, our cache control header is a very feature-rich weapon in our side when we're handling this kind of request and response. So for example, this is an example of a cache control value. And in this case, I'm instructing our resource to be only cached by the browser. I'm saying that it's supposed to last 1 week. And I'm also saying that if my cache expires and you need to fetch something, don't leave my user hanging. Just give them the stale data that you have while I fetch something new. And this is only the surface of what you can do with a cache control header. So you can basically handle your entire cache layer with this your entire data with this kind of cache layer. So with cache control headers, if you decide public, it's going to be cached everywhere or anywhere. So on the CDN, on the server, and so on. Or private, only in the browser. You can specify the max age in seconds. And you can define, OK, this resource is immutable. It's never going to change. So keep it like that. So you don't need to, ever need to expire, for example, my company's logo. So, well, if it's it might change, but anyways, that's. You can say every time you must revalidate this resource. Or you can say, again, like I did, give the user stale data while you're revalidating my stuff. You can also specify it to never cache this, because this is like something that changes very often. I don't want you to cache. And there's a lot more stuff that you can do. So just check the MDN docs. Like, they're very instructive about everything you can set. And in the end, it's a little bit tricky. It's a long string, but yeah, it has a very good examples. So back to our problem. Let's face our requirements again. We have opinions, we have priorities, and we have the integration to handle. So since our first tackle, we handled the opinions, and we handled the priorities because we wanted everybody to have their own app. And now we are handling the integration on an environment we can control. So I'd say we got that done. Great, because, well, that was what motivated us into changing our approach, right? Good, we fixed that. But let's take a step back and see what we are actually trading off here. So the first one is our first approach, like our different apps and as components, and the other one is with the Jamstack. So end-to-end ownership, check, both have. Priorities management, yeah, we can handle that with both. Some would say a little less because on the Jamstack side, because it's whole apps, there is a chance that more than one team ends up handling one app. But I'll just keep that one in my pocket, and we're going to talk about it in a minute. Integration, that was our problem on the first one. That's what we fixed on that one. So no surprises so far. Accessibility, it's an active work, but I would give the component library they don't have that, in my opinion, because we cannot circumvent the fact that we don't have JavaScript. So we need to resort to some kind of server-side rendering for that. And we have that with the Jamstack very easily. So I'll say they have that. I'll give them a check. Performance is, again, an active work. But to me, there's a fundamental difference between the first approach and the second. On a single-page application, we need to actively chunk our bundle. We need to actively split our resources. And we have to make constant effort that we don't ship duplicated dependencies. We need to make constant effort that we don't bloat our bundle. So I'll give it like a half no. And considering it is everything that I said before, on the Jamstack, to me it's the other way around, because we are serving static markup. So I would say that the Jamstack starts performant, and it's very likely that if we don't watch ourselves, it's very likely that it degrades. But it starts, it gives you out of the box, okay, that's the perfect performance that you can get on your app. And as you add features, well, just don't mess it up. So I'll give it a half check mark, because you still need to know what you're doing. On the granularity side, you have that for sure with the component library, because it's so very fine-grained, you can do whatever you want. You can ship like a button as a single app, or you can ship like the whole sidebar as a single app, so it's granular. And at this point in this talk, it's not granular to have the most granularity that we can reach is by route. So each page is going to handle one single app. And we can break it down with components, but it's not the point that we're taking right now. Or let's talk about it. So I'm taking this approach with Next.js and React because, well, I'm basically a React developer, and some other stacks might be able to handle that, but I'm not like the right guy to tell you, though the concepts still work. So React right now in stable is the 17, but version 18 is bringing with concurrent mode the server components. And the server components are supposed to be a type of component that's is rendered on the server. So every time your component's rendered, it's actually shipping it statically to your app. So because it's rendered on the server, we can achieve back that granularity that we had without having to worry about the implications to our integration part, because that's all handled in our server, so we can bloat the bundle as much as we want there, and we can load our resources over there. And when we are shipping only what the user is actually going to need. So and whenever it's going to update from the server again. So it doesn't matter if you're using Moment.js, DataFNS, whatever other library you think of. It's going to be done in the server, and any other resource that it doesn't need, it's not going to get. So I left you here a nice redirect for the RFC if you're more curious about it. But yeah, it's coming sometime soon. So now we're back into that own integration. Nothing changed. The only difference now is that we are already able to handle data, and we will be able to handle also entire components on that. So we got our granularity back. Nice. Basically, no trade-offs, in my opinion. That's a win. So OK. But I already talked too much. So let me show you some code. And if you want to follow along, or if you want to check this later, I also got a redirect for you. So Atila shift 2021, you can check the code on GitHub. So yeah, so this is the app deployed. As you can see, it's pretty much a default yarn create next app. The only difference here is that I'm about to show you is that this actually has two apps in here. So login is a completely decoupled app, and about is actually a page inside the main app. So these are two apps, the main and the login. And what I'm doing is that the login is just using next auth. That's the only dependency external from Next.js and TypeScript in this component, in this app. And it's going to use GitHub to log you in. And this session is going to live in my login app and is going to be fetched by my main app when I go to the About page. So I go to login. My login page is very elegant. And I just click login. And it's going to take me to the whole process of the GitHub authorization, blah, blah, blah. takes me back, and I get my info here. So that's my login page. And I couldn't make it more explicit, sorry, but you see it's a different app because it has a different color token. So it's a blue one, it's not my purple one. And I'm on the logged in page now. So I go back to my home, and I got a session now. So it's telling me hello. If I go to about, it's basically the same page as the logged in, but you see it's purple. So yeah, I'm on a different app, and I get everything from there. So how is it actually going to work for development? On development, I need to run both of my apps. Sorry. So on development, I need to run both of my apps, and I'm using concurrently for that. I have Yarn workspace, and it's just saying, OK, so run the dev task on login and run the dev task on main. One is served on 3000, one is served in 3001. And let me get my cheat here. And so what happens on the main app for Next, and this is a feature on Next.js called multi-zones. What's happening is that I have the main app that's going to orchestrate all this integration. And it's going to orchestrate this through rewrites, server rewrites. So I have one route here, which is the API auth. So every time you go to /API/auth something, it's going to actually redirect to my login URL, so where my login app is deployed, and it's going to serve the content from there. If I go to /login, it's going to, again, redirect to the root of the login URL, the login app. And if I go to login something, it's going to do the same. And this login URL is defined by environment variable. So as I scale, as I have more apps in my stack, I'm just going to have more environment variables, URLs, and I'll have to replicate all these rewrites as much as I need them. And boom, that's it. That's how you handle it. There's one caveat for Next.js is that Next.js has that link component that's going to handle your client-side navigation. And we are doing multi-zones here, so we are actually going to put them in their own, in our own routes, but our own route, but we are actually going to serve another app. And because we're using server rewrites, we cannot use client-side navigation because we need to give the server that hit to give us the response. Next.js doesn't know that on development, so whenever I use the anchor tag on my index over here, it's actually going to say, no, 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 you cannot do that because you're doing internal navigation. It's better for performance if you use the client side. So I need to go to my ESLint and say, OK, chill out. I know what I'm doing Next.js. That's fine. Thanks a lot. Bye. And after that, I can just head over to my login app. And in my login app, we are going to do two little things that are very important. The first one, in our next config, we're going to set the base path to /login because this app doesn't have a root. This app is served through the login. And another thing that is tricky, took me a few times to realize, this is how I'm handling the next auth. So the next auth gets this auth provider, and it cannot get the base path from the next config. So you need to explicitly hard code where it is the base path. But that's about it. After that, I'm just passing down the session to every page that is consuming that with a React context API. And the last thing and how we handle that is that inside, and here's our shared service. So on the API, I'm just passing in this funny-looking route here is actually recommended by Next Auth. So this is straight from their docs. So this is everything that I'm doing. I'm setting to use the JWT, so the JSON Web Token, and I'm setting to use GitHub as a provider. And that's about it. After that, everything is handled for us. So yeah, that's about it. And thanks a lot. And if you got interested into that and you want to know a little bit more about Next.js, just check the first link over there. I might have something for you. I'm going to also be doing some videos about the content of this talk on my YouTube channel. If you need anything, reach out to me on Twitter. I'm always happy to talk. And I'm going to tweet about the slides as soon as I upload them somewhere. And if you want to check the code, just go to that or look at my GitHub. Thanks a lot.